Super quick one today. We're going to go over the angle of inclination of a line. Okay, the angle of inclination gives us some pretty cool things about a line. So suppose we have a line on a Cartesian plane. And this is going to be for a straight line, just to be clear. It has to be a straight line on a Cartesian plane. Each line has an angle of inclination. Each line on my Cartesian plane is going to have an angle of inclination. Okay, and let me copy a graph onto my page. Alright, so let's say I have two lines. I'm going to draw two different lines. So I'm going to draw this line here. And I'm going to draw a blue line here. These two lines both have different angles of inclination. But how do we know what the angle of inclination is? What is the angle of inclination? Well, the angle of inclination, is the angle between 0 and 180. It will always be between 0 and 180 that a line makes with the x-axis. But this is the important part. Measured with the x-axis, makes the x-axis measured anti-clockwise. Measured anti-clockwise. So, that means we're starting here. It's the angle that the line makes with the axis starting here. So for example, for my first line, it's going to have this angle of inclination. For my second line, it's going to be a bit bigger. This is going to be its angle of inclination. Whatever value of theta that's going to be, that is that angle of inclination. Now we have to think, how does this help us? What does this do? How does this give us any sort of information? Well, changing the angle of inclination doesn't just change the angle, it also changes how steep my graph is. It changes how much up or down I'm going. It changes the steepness of our line. So let's draw a couple axes. So there and there. Alright, that's x, that's y. Well, what's another way I could think of the steepness of a line? Another way to think of steepness is the rate of change. It's really the rate of change of a line as I'm going up by x. If I've got my ruler here, and I'm going to have a line that's 23 degrees, right? Well, and let's just draw that in. I'll get rid of this after, you don't have to copy this down. That is increasing at a rate that is going to be a rise over run. How much do I go across? How much do I go up? How much do I go across? How much do I go up? Well, if I change how big my angle is, I'm actually increasing that rate of change. I'm getting bigger for every x that I'm going up. And for those of us that are really good at math, which we should be in this course, what can we relate that back to? We can relate it back to the gradient of the line. Which is the gradient of the line. So if I draw some line here, there we go. Okay, there's my line, there's my line. It's going to have an angle of inclination, and let's just call that theta. Well, we know that changing the angle changes the gradient. Well, my rise again, how are we going to figure that out? Well, my gradient equals rise over run. Rise over run, which equals the change in y over the change in x. Well, the change in y is sine theta. Remember, because we know that sine theta is the equivalent of our y coordinate over cos theta, which is the change in my x coordinate. And remember, this theta is our angle of inclination. And let's think back to what tan of theta is equal to. Sine theta over cos theta gives us tan of theta. So for any line that has an angle of inclination, the gradient is equal to the tangent of that angle of inclination. The gradient. I'll start with the gradient. The gradient of a line is equal to the tangent of the angle of inclination. So if you have any line and it cuts the x-axis and it makes an angle with that x-axis, if you find the tan value of that angle theta, then you will have the gradient of that line. So you find the angle here, and then you find the tan of that angle, and it gives you the gradient of the line.